In this lesson, we are going to treat how to resolve a given fraction into partial fractions. We are going to look at linear factors. By linear factors, we mean that the highest power of the denominator is 1. And partial fraction is just like algebraic fractions. In algebraic fractions, when we simplified, we joined two fractions together. It was a case where if we had 2 over x plus 1, let's say plus 3 over x plus 2, we simplified it and we got to a point where this became x plus 1 and x plus 2, and then when we divided the LCM by the denominator, we multiplied, we got 2x plus 2 plus 3x plus 1. Then we simplified, we got 2x plus 4 plus 3x plus 3 over x plus 1, x plus 2. Then this gave us 2x plus 2x, 5x plus 7 over x plus 1 and x plus 3. So this is simplified form of this. Now this form of the fraction is a partial fraction. This is a partial fraction, like the fraction is in parts, but this one is the expanded form of it. Now what we do in this part is that we want to resolve this one that is in simplified form to the part it was before it became like this. What I mean is that by the time we are done with the resolution, we're going to arrive at this form back. Just like you have sugar and then you have water. Okay, now if you put cubes of sugar into a glass of water, the sugar dissolves. You won't get the sugar back immediately. So if you want to get this, becomes a sugar solution. Now what do you do to get this sugar back? There's a chemical process separation technique that you need to apply to get the sugar back. So if you apply that principle and you get the exact amount of sugar back, that process is known as resolution, or resolving into resolving the solution in order to get the sugar back. That's in terms of chemistry or separation technique. But in mathematics, in order for us to get back the fractions that make this expression this way, or for us to get this expression, is known as resolution or into partial fractions. So by the time we are done with this, we should be able to get the fraction in this form, the initial form it was before it was combined to give us this unique singular fraction. So we're going to start with this example. There are two ways of resolving into partial fractions. I'll be treating the two methods. So I'm going to start with the first one. So this is method 1. Okay, so in method 1, I'm going to write out the fraction. I'm going to say let 2x plus 11 over x minus 2 and x plus 2 be identical to, so okay, equals to a over x minus 2 plus b over x plus 3. So the next thing we're going to do is, since this is the LCM of this simplified form of the fraction that we're trying to resolve into the various parts, we're going to say multiply through by the LCM, multiply through by the LCM, and the LCM is x minus 2, x plus 3. So let's do this. So x minus 2 and x plus 3, 2x plus 11 over x minus 2, x plus 3, identical to this side will give us x e bracket x minus 2, x plus 3 over x minus 2 plus b x minus 2, x plus 3 over x plus 3. Okay, so what we're going to do, we're going to cancel the common factors. On this side, these two brackets are similar to these two brackets that we have here, so it will cancel, give us 1, cancel, give us 1. So this will cancel and this will cancel. So we're going to have 2x plus 1, 2x plus 11 rather, equals to ax plus 3 plus bx minus 2. Okay, so at this junction, what we do is I'm going to eliminate. I want to eliminate one of the brackets. In order for us to solve for one unknown per time, I'm going to eliminate the other unknown. So let me say I want to solve for a first. So for me to eliminate b, I'm going to equate x to b plus 2. To eliminate b, let x, put x to equals to 2. So by the time x is equals to 2 and we put it here, plus 2 minus 2 will be 0, and 0 times b will be 0, so which means b will be eliminated. Then we can work for the value of a or solve for the value of a without difficulty. So this becomes whatever the value of x is here, also that's what it will be here also, and that's what it will also be in this bracket also. So 2 plus 11 is equals to a, 2 plus 3 plus b, 2 minus 2. So 2 times 2 is 4 plus 11, and then this is 2 plus 2 is 5a. Then on this side, 2 minus 2 is 0, 0 times b is 0, so this part is 0. Without, since it's 0, you can ignore it. So 4 plus 11 is 15, and it's 5a. Now divide both sides by 5, we're going to have a equals to 15 over 5. 5 here 1, 5 here 2, which is equals to 3. So the value of a is 3. Next is now I want to get the value of b. To eliminate a, this time around we're going to eliminate a. And how do we eliminate a? If you check your box here, the bracket here rather, you see that x plus 3. So what would you make x to be in order for it to be 0 when you add it to 3? It will be minus 3. So to eliminate a, put x equals to minus 3. So if x is minus 3, minus 3 plus 3 will make it to be 0. Okay, so 2, and wherever you put make x to be is what x will be here, and also what x will be here. So x is minus 3, so you have minus 3 plus 11 is equals to a minus 3 plus 3 plus b minus 3 minus 2. So minus 6, because minus 6 plus 11 is equals to minus 3 plus 3 is 0, 0 times a is 0, so it's eliminated. So this becomes minus 3 minus 2 minus 5 is equals minus 5b. So minus 6 plus 11 is equals to 5, and this is equals to minus 5b. So divide both sides by minus 5, b is equals to minus 5 over 5. 5 here 1, 5 here 1. Therefore, b is minus 1. Therefore, a is equals to 3 and b is equals to minus 1. Now, we have gotten the values of a and b. We are going to put substitute these values for a and b in this proposition. So I'm going to say substituting for a and b in our initial proposition. Our initial proposition was this, because we started off by saying that let a stand for a value and let b stand for a value, and we've gotten the values that a stood for, b also stood for. Now we need to put them in place of a and b. Okay, so our equation becomes, first of all, the initial equation was 2x plus 11 over x minus 2 and x plus 3. This is equals to, where a is 3 over x plus 3 over x minus 2. Now here, since the value of b is minus 1, if you put plus and then minus 1 over x plus 3, Minus times plus will give you minus, so it will become 2x plus 11 over x minus 2, x plus 3 is equals to 3 over x minus 2 minus 1 over x plus 3. That's the answer. So that way we have resolved this fraction into its various parts. So it was this fraction that was simplified to get this. That's what it implies. I just took you on the first method on how to resolve a given fraction into its parts. Now we're going to look at the second method. It's almost the same thing, but just that the second method we are going to either use substitution method or elimination method to solve for each of the unknowns that we put into a fraction. So let's proceed. So initially we got something like this. So we're going to say let 2x plus 11 be equals to x minus 2 and x plus 3. That they are identical to a over this first part, x minus 2 plus b, which is the second part. Okay, second denominator. Now we're going to multiply through by the LCM, which is x minus 2 and x plus 3. We're going to have x minus 2, x plus 3, 2x plus 11, x minus 2, x plus 3, identical to a x minus 2, x plus 3 over x minus 2 plus b x minus 2 x plus 3 over x plus 3. So this will cancel this, and this will cancel this, this will cancel this. Okay, so this will give us 2x plus 11 is equals to a x plus 3 plus b x minus 2. Now at this point, the second method, you're going to expand. So open the bracket, 2x plus 11 is equals to a x plus 3a plus bx minus 2b. Okay, to simplify, 2x plus 11. We're doing the ones that have like terms, ax plus bx, and then plus 3a minus 2b. Okay, 2x plus 11 is equals to x factorize a plus b. We factor the x out, a plus 2a minus 2b. Now, we can see that if we equate coefficients, we are going to equating coefficients or equating, simply by equating, we're going to have x. This part of this our expression will equate with this part, and this part will equate with this part. So we're going to have 2x equals to x a plus b. So this x will cancel this x. So a plus b is equals to 2. We call this equation 1. Then this other part, 2a minus 2b, will equate to this side 11. So this will give us equation 2. Okay, I want to use substitution method to solve this simultaneous equation. So from 1, make a subject formula. So a is equals to 2 minus b. This is equation 3. So we're going to put equation 3 into 2. When we do that, we're going to have, so when we say put equation 3 into 2, in equation 2, where we have a, we put the all of this value in place of a. So 3 2 minus b, okay, minus 2b is equals to 11. So 3 times 2 is 6. 3 times minus b minus 3b minus 2b is equals to 11. So we'll collect like terms. Minus 3b minus 2b gives minus 5b. 11 minus 6. So minus 5b is equals to 11 minus 6 is equals to 5. Divide both sides by 5, by minus 5. So we're going to have b equals to 5 over 5. These are minus 5 here 1, 5 here 1. So b is equals to minus 1. When 1 divided by 1 is 1. So we've gotten the value of b. So substituting minus 1 for b. Substituting minus 1 for b in equation theory. We have equation theory is a equals to 2 minus b. So a, in place of b, we're going to put the value we got for b, which is minus 1. So 2 minus 1. So a is equals to minus times minus gives us plus. So this gives us 2 plus 1, and a is equals to 3. So that's the answer. So from what we've done, a is equals to 3 and b is equals to minus 1. Therefore, substituting for a and b in our initial proposition, we're going to have this is the initial proposition, 2x plus 11 over x minus 2 and x plus 3. So this equals to, for a we have 3 over x minus 2, and it goes minus times plus, here it's plus, so minus times this plus will give us minus, so here will be minus, because the answer is minus 1. So that'll be minus 1 over x plus 3. So that's our answer. It's 2x. Okay, let me rewrite it so it can be visible. So we have 2x plus 11 over x minus 2 and x plus 3 is equal to 3 over x minus 2 plus, let's say, minus 1 over x plus 3. So minus times plus gives us minus, so 2x plus 11 over x minus 2 x plus 3 is equal to 3 over x minus 2 minus 1 over x plus 3. So that's the part of the fraction. We have resolved this fraction into its parts. That's the answer. So method 1. We say let x plus 3 over x minus 2 and x plus 4 be identical to a x minus 2 plus b x plus 4. So we're going to multiply through by the LCM, which is this parallel of this, and the LCM x minus 2 and x plus 4. We have here x minus 2, x plus 4, and x plus 2, x minus 2, x plus 4 equals to a x minus 2, x plus 2, x plus 4 over x minus 2 plus b x minus 2, x plus 4 over x plus 4. So this will cancel out, and this will cancel out. Okay, so we'll be left with x plus 3 identical to a x plus 4 plus b x minus 2. Okay, so we're going to eliminate. Let me eliminate b first. A. To eliminate A, the opposite of plus 4 is minus 4. Put eliminate A, put x equals to minus 4. In this way, minus 4 plus 4 will do is make it to a 0, and 0 times A is 0. So that means that A will be eliminated or has been eliminated by when x equals to minus 4. So x minus 4 plus 3 equals to minus 4 plus 4 is 0. 0 times A is 0. So A has been eliminated plus B minus 4 minus 2. So minus 4 plus 2 will give us minus 1 plus 2. Minus 4 plus minus 4 minus 2 is minus 6B. So B is equals to minus 1 over minus 6. Minus cancel out minus, so B is equals to 1 over 6. Okay, to eliminate B, put x equals to 2, which is the opposite of minus 2. So we're going to have 2 plus 3 is equals to A 2 plus 4. And here, plus 2 minus 2 is 0. 0 times B is 0, which means that B has been eliminated. Okay, so 2 plus 3 is 5, and 2 plus 4 is 6. This is just 16. Now divide both sides by 6, we're going to have 5 over 6. So this is the value for A, and this is the value for 1 over 6 value for B. So say therefore A is equals to 5 over 6, and B is equals to 1 over 6. Alright, now substituting for A and B into our initial proposition, which is x plus 3 over x minus 2 and x plus 4, where we said A should be x minus 2 plus B should be x plus 4. Now that we've got the values for A 5 over 6 and B 1 over 6, we're going to put each of these values instead of the values they stand and A and B was standing for. So here we will have x plus 3 equals to x minus 2 and x plus 4. Okay, this is equals to, so A here is 5 over 6. So this will give us 5 whole number 6 x minus 2 plus our B is 1 over 6. This will give us 1 whole number 6 x plus 4. So that's it. Okay, so that's the answer. Now let's take the second method. So let x plus 3 over x minus 2 and x plus 4 be identical to A x minus 2 plus B x plus 4. Okay. Multiplying through by LCM, which is x minus 2 x plus 4. We're going to have x minus 2 x plus 4 x plus 3 x minus 2 x plus 4 then structure A x minus 2 x plus 4 over x minus 2 plus B x minus 2 x plus 4 over x plus 4. So this will cancel out with this, and this will cancel this, and this so we'll be left with x plus 3 equals to a x plus 4 and plus b x minus 2. Okay, so now we're going to expand this part. So x plus 2 is equals to ax plus 4a plus bx minus 2b. So let's collect like terms. X plus 2 is equals to ax plus bx plus 4a minus 2b. So x plus 2 is equals to x a plus b plus 4a minus 2. Okay, so equate x with x. So say x a plus b equals to x, and then so this will cancel this, so you'll be 1. So a plus b equals to 1, just equation 1, and then 4a minus 2b is equals to 2, equation 2. Okay, I'm going to use elimination method this time around. Using elimination method, I'm going to have, so I'll multiply equation 1 by 4. So this gives us 4a plus 4b is equals to 4 times 1. Give me 4a plus 4a minus 2b is equals to 3. And then I'll subtract. So this will eliminate. Then minus times minus is plus. So 4b plus 2b is 6b. So 4 minus 3 is 1. So b divide both sides by 6. B is equal to 1 over 6. Substituting. So I'll put substituting 1 over 6 for b in. I can put the value of 6 in this or this, or in 2 or 1. So let me use 2. In 2, I'm going to have equation 2 is 4a minus 2b is equals to 2, where b is 1 over 6. So 4a minus 1 over 6 equals to 2. 4a minus 2 times 1 is 2. This is just 2 over 6 equals to 2 over 1. So the LCM of 1 and 6 is 6. 6 into 1 is 6. 6 times 4a, 24a. 6 into 6 is 1. 1 times 2 minus 2 equals to 2. So 24a minus 2. Okay. Over 1. So I cross multiply. 24a minus 2 is equal to this part. 1 multiply everything here will give us the same result. And 6 times 3 is 18. So collect like terms. 24a is equals to 18 plus 2. So 24a is equals to 20. Divide both sides by 24. A is equals to 20 over 24. Okay, so 2 here is 10, 2 here is 12, 2 here 5, 2 here 6. So a is equals to 5 over 6. Therefore, a is equals to 5 over 6 and b is equals to 1 over 6. Substituting for a and b in our initial proposition, which was x plus 3, which was x plus 3 over x minus 2 and x plus 4. So remember we said a over x minus 2 and a here is 5 over 6. 5, 6 x minus 2 plus b is 1 over 6. So 1 over 6 x plus 4. So that's the answer. So when given such a problem, that has different methods. You don't need to use both methods to solve the problem. You can choose which one you may decide to use, and which one you decide to use is your choice. So you can pick the one that will be easy or that's fast, or the one you are familiar with. So in an exam condition, you are not expected to use method 1 and method 2. I use both of them to show that either way, either method will give you the same answer. So you choose the one that you think is preferable or easier for you to be familiar with. So either method 1 or method 2 will give you the same answer. If 10x plus 1 over x minus 2 x plus 1 is identical to k over x minus 2 plus 3 x plus 1, comma, find the value of k. So solution, I want to find the value of k which made up the parts of this fraction. Okay, so let's 10x plus 1 over x minus 2 and x plus 1 is identical to k x minus 2 plus 3 x plus 1. So multiplying through by x minus 2 and x plus 1, which is the LCM, that is the LCM, we're going to have so x minus 2 x plus 1 10x plus 1 over x minus 2 x plus 1 equals to k x minus 2 x plus 1 over x minus 2 plus 3 x minus 2 x plus 1 over x plus 1. So all of this will cancel out, cancel. So we'll be left with 10x plus 1 is equals to k x plus 1 plus b x minus 2. Okay, now since I'm looking for the value of k, we need to eliminate b. So to eliminate b, put x equals to 2. So 10 2 plus 1 is equals to k 2 plus 1. So when you put 2 here, 2 minus 2 is 0, 0 times b gives 0. 20 plus 1 is equals to 2 plus 1 3 times 3k. Okay, this is 21 equals to 2k. 3k equals to 21. Divide both sides by 3. Divide both sides by 3. 3k over 3 is equals to 21 over 3. 3 and 1, 3 and 1, 3 and 1, 3 and 7. Therefore, k is equals to 7. Solution. Okay, so let's 1 r plus 2 be identical to a over r plus b r plus 2. So multiplying through 3 by r plus 2. This is the LCM. We're going to have r plus 2 times 1, which is 1 here, over r plus 2 is equals to e r plus 2 over r plus b r plus 2 r plus 2. Okay, so this will cancel. So we have 1. So we're going to have 1 equals to e r plus 2 plus b r. Okay, so can you rewrite? 1 is equals to e r plus 2 plus b r. Okay, so open our bracket to eliminate b. Okay, so to eliminate b, let r be 0. It's r equals to 0. So once r is equal to 0 here, 0 times b is 0. So here will be, so 1 equals to a r, which is 0 plus 2. So that's 2. So 1 is equals to 2a, and a is equals to 1 over 2. So eliminate a, put r equals to minus 2. So minus 2 plus 2 will be 0. 0 minus a will be 0. So 1 is equals to, place 0, come here, b minus 2. So 1 is equals to minus 2b, and b is equals to minus 1 over 2. So therefore a is equals to 1 over 2, b is equals to minus 1 over 2. Okay, so substituting for a and b in our initial proposition, which is 1 over r plus 2, which we say should be, so equals to a. So in place of a, we're going to put 1 over 2, so that's 1, 2, and a here is r, 1 over 2 r plus b. b here is minus 1 over 2 r plus 2, r plus 2. Okay, so let's simplify. This is equals to, so 1 over r plus 2 is equals to a is 1 over 2r plus times minus give us minus, so minus 1 over 2 r plus 2. That's the answer. Okay, we're defining the values of p, q, and r. So let's take the first method 1. Okay, so say let's 4 plus 2x plus 2x squared over 1 minus 2x, 1 minus x, and 1 plus x be identical to p over 1 minus 2x plus q over 1 minus x plus r over 1 plus x. Okay, so next we're going to do some multiply through by the LCM. And the LCM is, which is 1 minus 2x, 1 minus x, and 1 plus x. So by the time we multiply through this LCM on this side, this whole expressions will eliminate this part. So we left with this one on the left hand side, 4 plus 3x plus 2x squared. So we do same thing with this one. So this LCM divides the denominator. So this part will eliminate this part. So this part will remain. This part will less, and this part will now multiply p. So give us p over 1 plus x and 1 minus x, 1 plus x. Okay, you use the LCM to divide this denominator. It will eliminate this part because they are common factors, they are the same. So this part and this part will be less. So plus q will give us 1 minus 2x and then 1 plus x, then plus r is equals to, when you use the LCM to divide this denominator, this part will eliminate this part, will cancel because they are the same. So this one and this one will be less. 1 minus 2x and 1 minus x. Okay, so let's see this is okay. So the next one we're going to do is eliminate. I want to eliminate p and q. To eliminate p and q, put x equals to. So for me to be able to eliminate p and q, I want to look out for a common factor. What I mean is this: 1 minus x, 1 plus x. You check p and q, both of them have 1 plus x, 1 plus x. So if I make x here to be minus 1, it will automatically make this expression, this part of it to be 0 and this part to be 0. So 1 plus 1 plus times minus 1 will give me minus 1. 1 minus 1 will give me 0. 0 times what I'll get is bracket. 0 times what I will get in this bracket will be 0. 0 times q will be 0. So which means I have eliminated q. Same thing will apply here. Plus times minus 1. That is if I make x to be minus 1. So assuming it's like this, plus times minus 1 will be minus 1. 1 minus 1 will be 0. Of course, here will be minus 1. Minus times minus will be plus, which is 1 plus 1 to be 2. But here it's already 0. So 0 times 2 will be 0. 0 times p will be 0. So both p and q will be equated to 0 when x is minus 1. So in that way, I will have been eliminated p and q. So I will be left with r to work with. So to eliminate p and q, put x equals to minus 1. Okay, so with that, I'm going to put it to 4 plus 3 minus 1. 4 plus 3 minus 1 plus 2 minus 1 squared equals so r will be 1 minus 2 minus 1, and this side 1 minus 1. So 3 minus plus 3 minus 1 gives us minus 3. Minus 1 times minus 1 will give us plus 1. 1 times 2 to give us plus 2. So on this side, r minus 1 times minus 2 give us plus 2. 1 plus 2 give me 3. And then minus 1, minus times minus is plus. 1 plus 1 is 2. Is equal to 2. So 4 minus 3 is 1. 1 plus 2 is 3. 3 times 2 is 6. Will give me 6r. So divide both sides by 6. R is equal to 3 over 6. 3 over 1 get 2 is equal to 1 over 2. So our value for r is 1 over 2. So eliminate. We want to eliminate p, q, and r. So we can eliminate q and r. Put x. So let's look at for something that is common to both q and r. So q 1 minus 2x, r 1 minus 2x, good. So what we need to do is that both of them have 1 minus 2x. So if I make x half as 1 over 2, I'm going to get 0. This is what I mean. 1 minus 2, 1 and over 2. So 2 times 1 will give me 1 minus 2 over 2. 2 here 1, 2 here 1. This gives me 1 minus 1. So 1 times 1, 1 minus 1 will give me 0. Or if you don't want to go that like that, you just go 1 minus 2 over 2. Make it a fraction. The LCM is 2. 2 into 1, 2 times 1, 2. 2 into 1, 4. 2 into this will give me 2 minus 1, that is 2 into 2, that is equal to 2 minus 2 is 0 over 2, which is equal to 0. So with that, so assuming with that, here it becomes 0. So 0 times this will give 0. 0 times r is 0. And also here, this everything will be 0. 0 times this will give 0. 0 times q will be 0. So when we do that, we will have eliminated q and r, and that's what we want to do. So to eliminate q and r, put x equals to half, and x equals to half also affects this part of the equation as much as it affects this part of the equation. So this will give us 4 plus 3 half plus 2 half squared. So we are left with p. We've eliminated q and r, so we are left with p. So p is equals to 1 minus half and 1 plus half. Okay, so here it's 4 plus 3 over 2. 3 times 1, 3 plus 2 times 1 over 2 squared gives us 1 over 4, 2, 1 over 4 equals to p. So p 1 minus half is equals to 1 minus half is equals to LCM is 1, 2, 2 minus 1, which equals to 1 half. So here is half, and also 1 plus half. 1 plus half, LCM is 2. 2 into 1 is 2. 2 times 1, 2. 2 into 2 is 1. Okay, 1. That's equals to 3 over 2. So here's 3 over 2. Okay, now simplify here. This is 4 over 1 plus 3 over 2 plus 2 times 1 is 2 over 4. And this is equals to 3 times 1 is 3, 2 times 2 is 4. This is 3 over 4 p. So let's simplify here. The LCM of 1, 2, and 4 is 4. 4 into 1 is 4. 4 times 4 is 16 plus 4 into 2 is 2. 2 times 3 is 6 plus 4 into 4 is 1. 1 times 2 is 2, equals to 3 over 4 p, equals to 3 p over 4. Okay, so let's cross multiply. 16 plus 6 is 22. 22 plus 2 is 24. 24 over 4, which is equals to 3 p over 4. Cross multiply. Okay, so cross multiply. 24 multiply 4 from here. So this will give us 24 times 4 is equals to 3p times 4. So this is 3p times 4 equals to 24 times 4. So 12p is equals to 24 times 4. Divide both sides by 12, you're going to have 24 times 4 over 12. So 12 here 1, 12 here 2. 2 times 4 is equals to 8. So value of p is 8. So we are going to move on to eliminate further. So to eliminate this time around, we want to work for, we've got the value for p, we've got the value for r, so we want to solve to get the value of q. So we're going to eliminate p and r. To eliminate p and r, put x equals to, let's look at what p and r have in common. P has 1 minus x, r has 1 minus x. Okay, so p has 1 minus x, r has 1 minus x. So we're going to put x equals to 1. So in that way, if x is 1 here, 1 minus x is 0. 0 times this will give you 0 times r is 0. Same thing applies here. 0 times this, 0 times p, 0. So we're going to have only q to solve for with this side of the equation. So this will give us 4 plus 3, 1 plus 2, 1 squared equals to r, sorry, q. So q is equals to 1 minus 2x. 1 minus 2 is x, which is 1. And here 1 plus 1 plus 1. So 4 plus 3 plus 1 times 1 is 1 plus 2 equals to q over 1 minus 2 times 1 gives us 1 minus 2. 1 plus 1 is 2. So 4 plus 3 is 7 plus 2, 9 is equals to q. 1 minus 2 is minus 1. Minus 1 times 2 gives us minus 2q. And q is equals to minus 9 over 2. So therefore P is equals to 8, Q is equals to minus 9 over 2, and R is equals to 1 over 2. Now, we're going to put this in this expression. So substituting for P, Q, and R in our initial proposition is, so we have here 4 plus 3x plus 2x squared over 1 minus 2x, 1 minus x, 1 plus x is equals to P. The value for P is 8 over 1 minus 2x. Now Q is minus 9. So minus 9 is plus, we give minus 9 over 2, 1 minus x. And then R, what's the value of R? R is 1 over 2, so it's positive, plus 1 over 2, 1 plus x. So that's the answer. Okay, so let's look at the method, the second method. So let 4 plus 3x plus 2x squared over 1 minus 2x, 1 minus x, 1 plus x, let it be identical to P 1 plus x plus q over 1 minus x plus r 1 plus x. Okay, so multiplying through by LCM, which in this case is 1 minus 2x, 1 minus x, and 1 plus x. We're going to have 4 plus 3x plus 2x squared identical to P. And P here will give us 1 plus x. Sorry, P will give us 1 minus 2x and 1 minus 2x. Oh, sorry. Starts with 1 minus 2x. 1 minus 2x. So P will not give us this part. P will give us 1 minus x, 1 plus x. The reason being that when this denominator divides this, when this LCM divides the denominator, this 1 minus 2x will eliminate 1 minus 2x. So this remaining brackets will multiply P. So this is what we have, plus Q. Same thing applies. This one will eliminate this part. So we left with 1 minus 2x and 1 plus x. 1 plus x. Then plus R. This part will be eliminated. So we left with 1 minus 2x. 1 minus 2x and 1 minus x. Okay. Right. So that's what we're going to have. Now, what we're going to do in this second method is that we're going to expand each of these. We're going to expand each of the brackets. So let's start with p. P bracket will give us, let me write it here, 4 plus 3x plus 2x squared equals to, this will give us a p bracket. We will have p is 1 minus 2x and 1 plus x. So 1 times 1 is 1. 1 times plus x is plus x. Minus 2x plus 1 will give us minus 2x. Minus 2x plus x will give us minus 2x squared. So 1 plus x minus 2x will give us minus x minus 2x squared. So this is p 1 minus x minus 2x squared. So plus q. So for q we have 1 minus 2x minus 2x and 1 plus x. For q we have 1 minus 2x. Oh, what I did, this one is possible for q. Okay, so let me erase it. So for q, we put this in place, 1 minus x minus 2x squared. So for q, it's going to be 1 minus x, 1 plus x, 1 minus x, and 1 plus x. So 1 times 1 is 1, 1 times x plus x, minus x times 1 minus x plus x minus x squared. So we eliminate 1 minus x squared, 1 minus x squared. So plus r will give us 1 minus 2x, 1 minus x, 1 minus x. So 1 times 1 is 1, 1 times minus x is minus x, minus 2x times 1 will give us minus 2x, minus 2x minus x will give us plus 2x squared. So 1 minus x minus 2x minus 3x plus 2x squared. So 1 minus 2, 1 minus 3x squared plus 3x plus 2x squared. So that's going to be the result. 4 plus 3x plus 2x squared equals to p times 1 give us p minus px squared plus q times 1 give us q minus qx minus 2qx squared and so qx squared plus r times 1 give us r minus 3rx plus 2rx squared. Okay, so what we're going to do is that we're going to bring ones with like terms together. 4 plus 3x plus 2x squared equals to, so let's start with the constant. So this will give us p plus q plus r plus r. Let's group them together. Then the okay, next is coefficient of theory. So this will give us minus qx minus 3rx. Okay, there are 2. So then plus, then x squared, one with x squared minus 2x squared and minus p is p x squared and minus 2qx squared plus 2rx squared. Okay, we're not done. So 4 plus 3x plus 2x squared equals to p plus q plus r minus q minus x q plus 3 q plus 3r minus x squared we have p plus 2q minus 2r. So okay, let me see. So minus x squared times q minus px squared minus x squared plus 2q will give me minus 2q x squared minus x squared minus 2r plus 2rx squared. Okay, so now that we have done this, we need to equate. So equating, we're going to have, for this constant term, we're going to have p plus q plus r equals to 4, equation 1, and then minus x equals to, so here with minus x q plus 3r equals to 3x. So when we divide both sides by x, we're going to have here minus q minus 3r. Oh, okay. So here we minus q plus 3r equals to 3. So divide both sides by minus 1. So it will give us minus 1 over minus 1. So this will give us minus cancel minus. Here will be q plus 3r equals to minus 3. Equation 2. Okay, so come to this side. Minus x squared over p plus 2q minus 2r equals to plus 2x squared. So x squared will cancel x squared. Minus 1, divide both sides by minus 1. So in this minus 1. So this side will cancel. So we have p plus 2q minus 2r equals to minus 2. This will give us equation 3. So let's solve from here. Okay. So take a look at it. Now we have equation 1, equation 2, equation 3. So from equation 2 has just two variables to work with. So we're going to say from equation 2, q is equals to minus 3r. Call it equation 4. So we're going to put equation 4 in equation 1. So if you do that, put equation 4 into 1 in place of q. So we're going to have p plus 2, that's minus 3r plus r equals to what? 4. So this will give us p plus minus minus equals minus 3, plus minus 3r plus r equals to 4. So minus 3r plus r will give us p minus 3 minus 2r equals to 4. P minus 2r equals to 4 plus 3. P minus 2r equals to 7. So p minus 2r equals to 7. So here we got put 4 into 1 in place of q. We got this. So I'm going to say put equation 4 into equation 3. So in equation 3 we have p plus 2q minus 2r equals to minus 2. So in place of q we are going to put equation 4. So p plus 2. Equation 4 is minus 3r minus 2r equals to minus 2. So p plus 2 minus 3 gives us minus 6, plus 2 times minus 3r gives us minus 6r equals to minus 6r minus 2r equals to minus 2. So let's collect items. P minus 6r minus 2r gives us minus 8r. Then this minus 6 will cross over to give us minus 2 plus 6. So this is also my p minus 8r is equals to 4. So now I'm going to, using elimination method, so p minus 2r is equals to 7 and p minus 8r is equals to 4. So let's subtract. So p cancel, minus times minus is plus, 2 minus 2 plus 8 give us 6r plus 7 minus 4 is 3. 6r is equals to 3. Let me divide the board here. So 6r is equals to 3. And therefore divide both sides by 6. R is equals to 3 over 6, which is equals to 1 over 3. 3 is 1 over 2. Yeah. So R is 1 over 2. Now what we do is that we look at this equation, which of them, okay, equation 4. In equation 4, we're going to look for Q. So from equation 4, Q is equals to minus 3r. So Q is equals to, in place of r, we put 1 over 2, plus minus 3, 1 over 2. So Q is equals to minus 3 times 1 will give us minus 3 over 2. Okay, so put your h over 1. So you look for LCM. Q is equals to, the LCM is 2. 2 into 1 is 2. 2 times minus 3 gives us minus 6. 2 into 2 is 1. This gives us minus 3. So Q is equals to minus 9 over 2. Okay. So now that we know the value of R and Q, we're going to use equation 1. Because equation 1 has P plus Q plus R equals to 4. So from 1 is, you can say Q, P plus Q plus R is equals to 4. So the value of R and Q are already known, so we're going to substitute them in place of Q and R here. P plus our Q is minus 9 over 2, plus our R is 1 over 2, which is equals to 4. So we're going to simplify this part. P minus 9 over 2 times minus equals minus 9 over 2 plus 1 over 2 equals to 4. So LCM is 2. So 2 into 1 is 2. 2p minus 9 plus 1 equals to 4 over 1. So minus 9 plus 1 will give us 2p minus 8 over 2 equals to 4 over 1. Cross multiply. So this is 2p minus 8 equals to 8. And 2p is equals to, this one crosses over to give us 16. And p is equals to 8. Okay, so finally we've gotten the value for P, 8, value for Q, minus 9 over 2, and value for R, 1 over 2. So substituting for P, Q, and R in our initial proposition, where it was 4 plus 3x plus 2x squared over 1 minus 2x, 1 minus x, and 1 plus x. So we said P is 8 over 1 minus 2x, and Q is minus, negative, minus 9 over 2, 1 minus x, and then R is plus 1 over 2, 1 plus x. So that's the answer when we use the second method.